Okay, so we were talking about factoring. This one, we're looking for numbers, sets of numbers that multiply to make 20, and we need to get them to add up to -9. So you can see that 5 and 4 are going to work as long as we make both of them negative, right? Because -5 times -4 still gives me +20, but when they add together, they get -9. So the numbers that I need are these ones, right? 5 times -4. To write my answer, x minus 5, x minus 4, right? And remember, if you're ever stuck on one of these ones, right, you simply FOIL it, or sorry, if you're stuck. If you're not sure if what you did is right, you just FOIL it, and you can easily check, right? We have you'd have x squared, then you'd have a minus 5x, then a minus 4x, and then a plus 20, and of course that's x squared minus 9x plus 20, which was our original question, right? You should be able to go back to your question if you've done it right. This one, again, we'll just pick up our speed a little bit. I'm looking for two numbers that add up to 10 and multiply to 25. Those two numbers are +5 and +5, right? And, you know, of course, they multiply to the right value, and then they add up to 10, and you can FOIL to check your work on that one. Now, when you're looking at one like this, these last two I think are both good ones to investigate, just because, you know, they're slightly different, or they look like they don't belong in this section, right? So you go back to the title of this section, it said simple trinomials are trinomials where the leading coefficient, right, the number attached to the x squared, is a 1. And, you know, it was a 1 here, because all we saw was x squared. It was a 1 here, all we saw was x squared. It's a 1 here, and then all of a sudden here it's a 3. Now the reason this question is in this section is because before you even try to factor a trinomial, you should always look for a greatest common factor first, right? So like the type of factoring we did at the beginning of the day in part A, you should always try that first, because if you see that early in the question, the rest of the question becomes easier. So what we're going to do here is we're going to factor out a 3, right? Then we have our x squared plus x minus 6, which is what we're actually going to be working with, right? Once you pull a 3 off of all three of those terms, that's what you have left. Now what I'm looking for, a is 1, a is 1, b is also 1, and c is -6. So I'm looking for numbers that multiply to -6. I have -6 times 1, -3 times 2, -2 times 3, and -1 times 6. It has to be one of those options. All I'm doing is I'm looking through for the one that adds up to 1, and that one is of course here, the -2 and the +3. So my answer, right, I write the 3 because that came out before I did the factoring, but the trinomial in the bracket, right, so if we want to think of it like this, you could put that in another bracket if you want. We have x minus 2 and x plus 3. Now, of course, that extra bracket really isn't necessary, so you can just write it like that. But I just kind of want you to think about where that 3 came from, right? It's kind of like we did it at the beginning, and then we put it to the side, and then we came back to it. This last one is similar. I want to remind you that when you see a question that is not in descending order, you can just put it in descending order. So we could change this question to that, and it doesn't make any changes, right? With the negative stayed with the y squared, the 7y is positive, and the 8 is positive. Now, for our technique to work here, we need that y squared to be a positive number. So what I'm going to do is I'm going to factor the negative out of the bracket, which basically just changes the sign of everything in the bracket, right? So the y squared is positive now, the 7y is negative, and the 8 is negative. Again, you can check if you did this right. If you did it right by expanding the minus sign. And of course, you should go back to what you started with. Now that the question looks this way, we know that the answer is a sum, right? Our A, again, is 1. Our B is -7. Our C is -8. So I'm looking for things that add up to -7 and multiply to -8. the numbers that I need here are going to be negative 8 and positive 1, right? Because those numbers multiply to make negative 8, but they add to make negative 7. So what happens in this question, you have the negative from your first step, that doesn't change. Then we have a y minus 8 and a y plus 1, okay? And that is the factored form of the original question. And again, if we're not sure about this, we take it over to GeoGebra, we'll write, I'm not going to work with x's because it doesn't really matter what variable we use. So negative bracket x minus 8 bracket x plus 1. So that's what I've said the answer should be. Sorry, that's actually not what I meant to write. Wrong bracket there. Right, so it looks like that. And what I want to do is I just want to check that that's the same thing as the original question we had. Okay, that's the original question we had. And you can see that, yeah, they're the exact same graph, so I did it right. Okay, now when we get on to the last part of today, it's called a complex trinomial, right? And a complex trinomial is when that leading number at the front is not 1. And they get a little bit harder like this, although not much harder, just a couple of extra steps to pay attention to. I want to point out here that there are multiple ways of doing this. If you learned last year the box method or Mr. Cow's method or any other method, that's fine. The method, you can use that. It's no big deal as long as it works. The method I'm going to show you is decomposition. I always use decomposition because it was the way I was taught. It's a little longer than some of the other methods, but I find it more consistent. Again, the other methods work. They will always work if you do them right. It's not that, it's just the one I'm sort of most used to, so it's the one that I'm going to use. So when you write it now, okay, A is 3, B is negative 10, C is 8. What we are looking for now is a sum of B, but a product of A times C. Okay, so instead, in the old ones we were looking for just multiplied to C. Now we're looking for multiplied to A times C. So in this case we want a sum that adds up to negative 10, and we want a product that adds up, that multiplies to 24, right, which would be the 8 times the 3. Now the two numbers I'm looking for here are negative 6 and negative 4, because negative 6 and negative 4 add up to negative 10, and they multiply to make 24. Now what makes this different from the regular type of factoring is what we do next. What you do here is you take that negative 10x in the middle of the term and you decompose it. You separate it into two pieces. So what I'm going to do here is I'm just going to use a different color just to kind of highlight what we're doing here. Let's just make, so you see where it used to say negative 10x. Now what I do is I write the two numbers that I found. So instead of writing negative 10x, I decompose it into negative 6x and negative 4x. Of course, the statement I came up with is equivalent to the one above it, because if you simplify it, that's what you get. But it's written now in such a way that what I can do is I can GCF the first two terms and GCF the second two terms. And what will happen is I should get a bracket that repeats. So looking at this now, I have 3x squared minus 6x. I want to factor those two, and then I want to factor those two sort of separately. So let's change some colors just to illustrate kind of what we're doing here. So I'm factoring the two green numbers, and then I'm going to factor the two purple numbers. Okay, so looking at the green numbers, I can see that they both have a 3x. What would be left is x minus 2. When I look at the two purple numbers, what I see is they both have a minus 4. What would be left is x minus 2, right? Now if I did this right, what should happen is that this bracket, x minus 2, should be common, which means I can factor it to the front, okay, and then I can just collect whatever's left behind. Whatever's left behind here would be a 3x from the first chunk of the question and a minus 4 from the second chunk of the question. Now this is done, it's factored, everything is in a bracket, And again, just to check to see that it's right, we could start with our question, 3x squared minus 10x plus 8. You can ask GeoGebra to factor that, and we get exactly what I just said, x minus 2 and 3x minus 4. Again, practice this one, please. If you use a box or a different method, that's fine. If you're using decomposition, make sure you follow through this technique and you know how to do it, so that it's reliable. Let's try another one. Here we're looking for a sum of 13 and a product of negative 30. Now when you know the product is negative, you know that one number is positive, one number is negative. I can see that the numbers I'm going to need here are a positive 15 and a negative 2. They're what's going to add up to the 13, and they're going to multiply to the negative 30. Again, let's write it out the way we're supposed to write it out. 6x squared plus 15x minus 2x minus 5. Now again, I'm going to GCF the first two, I'm going to GCF the second two. In the first two, there's a 3x that I can remove. 6x squared divided by 3x is 2x. 15x divided by 3x is 5. So that's what's left over, right? 2x plus 5. In my second equation, I can factor out a negative 1, and what I have left is 2x plus 5. Again, I know I did this right because this bracket here, the 2x plus 5, is the same as this bracket here, which means that it can be factored to the front, and whatever's left over can be collected. Okay, so the 3x and the minus 1. Okay, so that's how you would do that one. Let's move on to this last one. I'm looking for a sum of negative 22 and a product of positive 40. Now, if the product is positive, it means you're either working with positive positive or negative negative, right? Because you're multiplying them to make a positive number. Since it has to add up to a negative number, I know what I have to do here is two negatives. So I'm looking for two negatives that add up to 22 and multiply to 40. The two numbers I need are negative 20 and negative 2. Okay, they would multiply to 40, they would add up to negative 22. So I write out the equation. 10x squared take away 2x, take away 20x plus 4. Now I want to point out this time that I put them in the other order. I put the 2 first and the 20 second. It does not matter which order you put these two in. You could do minus 20 first and minus 2 second, it still works. Looking at the first two terms, sorry, I'll just move this to a new page so you got more room. Looking at the first two terms, I can factor out a 2x. What would be left behind is 5x minus 1. Okay. Looking at the second two terms, I can factor out a minus 4. And what would be left is a 5x minus 1. Again, my two brackets are the same, so I bring them to the front, and then I can factor out a 2x minus 4. Now actually, I noticed in this question that I could have made it easier on myself if I had noticed that this bracket actually has a common factor, right? It has a 2 that you can take out of that bracket. You can put that 2 at the front if you want. Because everything's being multiplied, it doesn't really matter, and the final answer looks like this. Now, a smarter way of doing this would have been to look at the question in the first place and divide out that 2. I didn't notice that because I'm kind of rushing, but if I had taken out the 2 at the beginning, then I would have had an easier question to deal with. I would have been looking for something that multiplied to 10 and added up to negative 11. It might have been easier for me to see that they were negative 10 and negative 1. So, again, if you see a greatest common factor, you should always do that first. Okay, let's quickly just to show you what this would look like. 10x squared minus 22x plus 4. We factor out a 2, we get 5x squared minus 11x plus 2, and then I said that one, it works out to be minus 10x minus 1x plus 2, and it's a bit easier to take out what you need here. So you get 5x x minus 2, and then minus 1 x minus 2, and you end up with that 5x minus 1 and x minus 2, which is still the same thing we had before. Sorry, that actually makes me realize I made a mistake up there. I'm going to pause this and we'll just take up the last question.